Hello all, welcome to AI Educator. In this video, let us learn about mathematical imputation of backpropagation. First, let us look into some of the notations that we are going to use. X is the input, W is the weight, Z is the cumulative sum of input and weights, O is the output of hidden layers, and L is the loss, Dou is the partial derivative. Now, let us understand how the data flows. First, let us look into the data flow in forward direction. Consider we have a neural network with input layer with 4 nodes, first hidden layer with 3 nodes, second hidden layer with 2 nodes, and output layer with a single node. Now, x1, x2, x3, x4 are our inputs. And let us consider the weights of the connections here with W1. For Z11, we'll get a cumulative input of x1 W111 plus x2 W221 plus x3 W131 plus x4 W141 plus a bias of p1. In a similar way, we can calculate the z12 and z13. Here, these four are the weights or the connections for this node. Okay, these are the weights for the second node, and these will be the weights will be going with the connections to this node. Okay, and the output of the hidden layers for the O11 will be the activation function on Z11. Okay, in a similar way, we can calculate O12 and Z12, and we'll get a cumulative sum of input O11 W211 plus O12 W221 plus O13 W231 plus bias P2 to the Z21. In a similar way, you can even calculate for Z22. Okay, these will be the weights going to this node, and these three will be the weights of the connections which will be going to this node. We have already learned the weight notations that for the weight we'll be having a notation of W2 2 that means it is in the second layer and coming from the third node going to the second node. Okay, that is what we call W232. Okay, now the output of this second hidden layer will be O21 and O22, which will be the activation functions on Z21 and Z22, and again a cumulative sum of this O21 W311 and O22 W321 will go as Z31 to the output layer, which will be activation function on Z31. We'll get a predicted value. We subtract it with the expected value and we get the loss. Now let us look into the data flow in backward direction. First, we find out the dou L, which will be the derivation of the loss. Then we'll find out the derivation of dou Z31. Okay. Then we'll derivate the weight in that layer. Then we derivate the output of the hidden layers. Then again, we derivate the input of the second hidden layer. Then we derivate the weights in this layer. Then we derivate the output of the first hidden layer. Then we derivate the input of first hidden layer, and then we derivate the weights of that layer. Now let us try to understand the chain rule which we'll implement in the math. Let us consider a derivative dou y by dou x. First, we'll multiply it with 1. Okay. Now, in the place of 1, we take dou z by dou z. If we cancel both the dou z's, we still have dou y by dou x. Now, we interchange the denominators, which will result in dou y by dou x is equals to dou y by dou z into dou z by dou x. This is the chain rule. Now, let us look into the math. First, let us find out the weights in the third weight layer, which is dou L by dou W3s. There we have two weights, dou W311 and dou W321. Okay. First, let us calculate the dou W311. In order to go to dou W311, we need to go from dou L to dou Z3. From dou Z3, we can go to dou W311. Okay. So which will be dou L by dou W311 is equals to dou L by dou Z31 into dou Z31 by dou W311. In a similar way, we can find out dou L by dou W321. Okay, which will be dou L by dou W321 is equals to dou L by dou Z31 into dou Z31 by dou W321. Okay, now let us calculate the weight in the second weight layer. Let us calculate the dou L by dou W2s. Here we have 6 weight layers, 6 connections. So 6 weights. Okay, 3 weights will be going to this node. They are W211, W221, and W231. And 3 weights going to this node, and they are W212, W222, and W232. Okay, now let us calculate the W211. In order to go to W1, first we need to go from dou L, we need to go to dou Z31, and from dou Z31 to dou W311, and from dou W311 we need to go to dou O21, O21. From O21 we can go to Z21. From Z21 we can go to W211, which will be dou L by dou W211 is equals to dou L by dou Z31 into dou Z31 by dou W311 into dou W311 by dou O21 into dou O21 by dou Z21 into dou Z21 by dou W211. In a similar way, we can calculate the dou L by dou W211 and dou L by dou W231. Okay, since they all will go in the same path. Okay, so in order to go to this two also, you need to follow this way only. Now let us try to find out the weights which will go to this node. Okay, in order to go to W212, first we need to go to dou L to dou Z31, from dou Z31 to dou W321, from W321 to O22, O22 to Z22, Z22 to W212. Okay, which will be this connection, which will be dou L by dou W212 is equals to dou L by dou Z31 into dou Z31 by dou W321 into dou W321 by dou O22 into dou O22 by dou Z22 into dou Z22 by dou W212. In a similar way, we can find out dou L by dou W222 and dou L by dou W232, which will be going to this node. So in order to go to even these connections, we have to go in this way only. Okay. Now let us try to calculate the weights in this first layer. Let us calculate the dou L by dou W ones. In this first weight layer, which is the connections in between the input layer and first hidden layer, we have 12 connections. So we have 12 weights. Okay. Let us try to calculate one by one. First, let us divide into 3 parts. First, let us calculate all the weights coming to this node, then coming to this node and coming to this node. Okay. So for this node, we'll be getting four connections. So there will be 4 weights, which are W111, W121, W131, and W141. In order to go to W111, first we need to go to dou L to dou Z31, dou Z31 to dou W311, and from dou W311 to O21, from O21 to Z21, Z21 to W211, from W211 to O11, from O11 to Z11, and from Z11 to W111. We can also go in this direction also, which is dou L to dou Z31, from Z31, W321, W321 to O22, from O22, W212, W212 which will be the connection between these two nodes, from O11 to Z11, Z11 to W11. So which would be this dou L by dou W111 is equals to all the big equation. Here we are taking place because we can go in two directions to W111. In a similar way, we can calculate the dou L by dou W121, dou L by dou W131, and dou L by dou W141. Okay. Now let us calculate the weights for this node, coming to this node, all the connections. There are again four weights coming to this node. They are W112, W122, W132, and W142. So in order to go here, go to these connections, you can again go in two ways. One going from here and from there to this node, okay, and here, or going from this node to this node, again from this node to this node, and this, and the weight layers or the connections here. For dou W112, we can get this equation, and here also we have plus because we can go in two ways. In a similar way, we can calculate the dou L by dou W122, dou L by dou W132, and dou L by dou W142. Now let us calculate the weights of the connections which will come to this node. Okay. For this node, we'll be getting four more connections and four more weights. They are W113, W123, W133, and W143. And we can also go two ways to this node in order to go to the connections. The first way is to go from this node to this node and from this node to this node. Okay. And another way is from going from this node to this node and from this node to this node and to the weight connections there. So the dou L by dou W113 will be something like this. And here also plus because we can go in two ways. In a similar way, we can calculate for dou L by dou W123 and dou L by dou W133 and dou L by dou W143. Since we know how to calculate this dou L by dou W, let us see an example so that we can understand it easier. So this is the weight formula. W nu is equals to W old minus eta dou L by dou W old, where W nu is my new weight, W old is my old weight, eta is my learning rate, and dou L by dou W is the rate of change of loss with respect to weight. Let us consider my W old is 5 and I have a learning rate of 0.1, and I'm using an equation of loss, which is L of W will be W square and dou L by dou W will be 2W, which would be dou L by dou W old is equals to 2 into 5, that is 10. Okay. Now we got all the values. Let us put it in this equation. So my W new is equals to 5 minus 0.1, my learning rate, into dou L by dou W old, which is 10, which will result me into 5 minus 1, which is 4. If I have a weight of 5 and learning rate of 0.1 and my dou L by dou W becomes 10, then my new weight will be 4. Okay, this is how the weights will get updated. Okay, you don't need to mug up any of these equations. If you just write optimizer is equals to Adam or MSC prop or SGD, they will do all these calculations and will update the weights. Okay, this is just for your understanding. Okay, in the next video, let us learn about vanishing and exploding gradient.